Boys and girls, welcome to TDO. My name is TT, and today we're gonna be dealing with an assembly drawing. So let's get right on to it. Now, when it comes to an assembly, there's plenty of details to refer to. Just like this case right here. Question 3 says Figure 3 shows primary views of the components of an adjustable roller jack assembly. The complete list of parts is as follows. Now you are given the part list in the form of a table. Just like it's shown here, you have the item number, and then you have the description, which is the name of that item, and then you have the quantity representing the number of those items. Alright, now you are required to draw to scale 1:1 an assembly drawing of a full sectional front view of an adjustable roller jack assembly with the center of a roller 180 millimeters above the bottom of the base. Let's go and check out the part. Before we carry on to the lesson, it is my greatest pleasure to let you know that I've done some research and came up with something specially made for you, which is engineering drawing course for beginners. So if you are interested, there is a link in the description. You can just click it there, which is gonna take you to this page right here. We start from the very basic of engineering drawing, such as reproduction drawing. It's also broken down into pieces, so we're not rushing anywhere, just being fed the knowledge a bit by bit until you get the hang of it. So it's from the very basic all the way up to the more advanced stuff, and then going to the isometric, it's also broken down to pieces. We start by the isometric positioning. We start by explaining that first, and then we jump to the isometric drawing itself, isometric circles after, and then at the end is iso polygons. So these are all the tools that you will ever need in order for you to understand engineering drawing. So if you are interested, you come back to this page after clicking the link in the description. You scroll down to the very end, and then there are packages right there. There is a membership option, and then there is a once-off option right there. So in a membership option, you can pay on the monthly basis and get access to all the curriculum right there. And then on the once-off payment option, you just pay only once, you get the full access forever. It will be up to you to choose the option that you're gonna be comfortable with. But all in all, I would pretty much appreciate your support. Alright, that's it. Now let's go back to the lesson. Alright, so now we have the parts here along with the dimensions, which is another form of detail to refer to. So now the first thing that you do when you want to tackle an assembly drawing is you have a part 1 there, you have a part 2, 3, 4, and then you have 5 and 6. So these part numbers right here, these part numbers, they are not just labels, they're not just part numbers for you to distinguish between the parts, but these part numbers is you can also refer to them as the level of importance of the part. The first part is also, you can also refer to it as the most important part, part number 1, because that is the base. Usually most of the time part number 1 is always the base part, the main part of that component, the main part of that machine or whatever that you are required to assembly. So part 1 is the main part, like the primary part, whereby all the other parts they come together and they get connected to what? To the main part. So the main part is number 1. The second important part is number 2, number 3, number 4. It goes like that. So that's the first thing you should do if you don't want to get lost in an assembly, because there are so many machines out there, there are so many tools, there are so many components that you can be required to connect. Obviously you're not going to know all the existing components, you're not going to know all the existing machines. So for instance, this one, they said it's a roller jack. Maybe we've never seen a roller jack before, you don't know how it looks like. So you just forget about that. You focus on the given detail. You can connect any pieces that are given to you in a form of an assembly if you're going to follow my steps that I'm going to give you here. So you rate the parts. Part number 1, you pay attention to part number 1, part number 2, part number 3, all the way up to the last part. And then the second thing that you do, you pay attention to what? To the projection symbol that has been given. So this projection symbol here is what? Is a third angle orographic projection. So since this is a third angle, taking part number 2 right here, you see you have number 2 and you have 2 arrows pointing at that part and also that part. So this is part number 2. This is still part number 2 and this is still part number 2. So why does it have 2 views? That is where the orographic projection science comes in now. You have 2 views, the one on the left hand side and the one on the right hand side. And you are given the projection sign as what? As the third angle. So that means this is your front and this is your right view, because you have two views, shoulder to shoulder, side to side. The one is on the left hand side and the one is on the right hand side, and you are given the projection symbol, so you know this is the front and then this is going to be your right view. Same thing applies on part number 4 right here. Part number 4 has two arrows pointing, this part at the top and this part at the bottom. So since this is a third angle, what's at the top is the top view and what's at the bottom is the front view. So this is the front view of part number 4 and this is the top view of part number 4. How does it look like when you are looking at it from the top view? So now let's identify our part. We have part number 1 as the base, just like I've said it. Part number 1 is the base, which is part number 1 right there. You have your base right there. And then you have part number 2, which is the roller cradle. Given as the part number 2, this is the roller cradle. And then you go to part number 3. Part number 3 is this part right there, which is the what? Is the roller. Part number 3 is the roller. And then you have the adjustment wrench. Part number 4. Part number 4, you have the adjustment wrench right there. And then part number 5, you have the pin. And then part number 6 is the key. They only gave you a single view for part number 5. So you don't panic, you don't need two views for part number 5, because that simply means that even on the side it looks like this. That's why they only gave you a single view. They only give you two views if the side view of that part is different from the front view. That's why they give you two views, to show you the side part of how it looks like. But then here, they've only given you a single view, which is the front view. It's always a front view. When there's a single view, it's a front view. They've given you a front view only because it doesn't matter where you look at this rod from, it's always going to look the same. That's what they mean by that. Same thing applies for part number 6. So you go to part number 5, which is the threaded rod, and then part number 6 is the pin or a key. So you have part number 5, the threaded rod, and then part number 6 is the key. So now we are done identifying the part. So after identifying your part, the next thing that you do, you start the connection process. But before you start the connection process, you have to imagine all these parts in a 3D manner. You have to imagine all these parts in a 3D view, because here, you're always given 2D views. You have to combine the two views and then you come up with what? With the 3D views. So now the next thing you do, you use your orthographic projection skills to what? To convert this 2D part into 3D part, so that you can be able to get a clear path on what connects to where. Alright, we have part number 1 as the base. Let's get in reality and analyze how does the base looks like. So you have that hidden details right there. You should use them along with your orthographic projection skills to come up with a 3D view of that base. So I've already done that, and this is what I came about. This is the base. How does it look like? Exactly like this. This is how the base looks like. The front view of the base looks like this. And then if we were to show what hidden details, you are gonna see exactly what is visible where on this question as the hidden details. This is what you see, which is the same thing over here. Now let's move to the second part, which is part number 2, the roller cradle. The roller cradle has two views right here, which is the front view and the side view, which in reality, when you combine these two views, you come up with something like this. This is the front view of that roller. Let's go and confirm. This is the front view. And then let's check over the side view. The side view is supposed to look like this. So you go back to your roller, you check your what? Your right view. This is what you have, which is exactly how it looks like on the other side. Alright then. The next thing, we have two holes, which is the big one that is at the center, and then you have the 5 millimeter hole that goes through from the front side of the cradle, which is the space for what? For the pin. There is that diameter 5 hole, and then you have your what? The diameter 18 hole, represented by hidden details on the front view. And then that diameter 18 hole is the hole that is at the middle of that cradle. The bigger hole is represented by hidden details right there. And then there is another hidden detail which tells you that the hole is at the center. And then after that, you move to part number three, which is the roller. And same thing applies for part number three. They've only given you a single view, which means in order for you to come up with a 3D view of this roller, you don't need a side view. You can just do it using the details from the front view only. So notice how the side of this roller is represented by diameters. We have diameter 50, diameter 10, we have diameter 18 on the other side, which means this thing, when you look at it from the side view, is what is a circle. It's not a square, it's not a triangle, it is a circle. How do you know that? Because the dimensions that are given, they came in what? In a form of a diameter. You know that diameters are only used to mark what? To mark circles. So you know that the side view of this thing is just a plenty of circles, which is the first circle is diameter 10, the second one is diameter 18, and then that huge one, the last one, is diameter 50. Even the center part that is there is marked diameter 20, which means this thing is a circle. So let's go over and convert it from 2D to 3D. So in a 3D form, it looks like this. This is the roller. You have the diameter 10 right there. You have the diameter 18, and then you have the diameter 50. So this is how the roller looks like. And then the front view of the roller looks like this. This is the front, which is the same thing as what you're seeing right there. All right, now let's move on to the following part. Following part is part number what? Part number 4. The following part is part number 4, which is the adjustment range. So we have the top view, which means your 3D part in your mind from the top, it should look like this. And then from the front view, it should look like this. So the front view of the adjustment range, it's given like this. This is the front view. This is the front view right there. And then you have the what? The top. Top view, exactly like this. You go and confirm your top view. This is exactly the same. Now we shift to part number 5, which is the what? The threaded rod, part number 5. The front view of that part is just a 96 long rod with the threaded part, and then we have that tiny head that goes 12 millimeter high, and then we have that tiny hole on that top that is of diameter 5. So in reality, this is what a threaded rod looks like. This is what should come to your mind. Because why do you know this thing is threaded? Because you know that these lines that are in the middle, you have this line going down, and then you have another one on the opposite side, and then you have the one that goes across. That is how you represent threads in what? In engineering drawing. This is how you represent thread. As soon as you see lines like this, as soon as you see this view, it means all this part is threaded. From that top line all the way to the bottom, it's all threads. If these two inner lines, they were ending somewhere at this point right here. Now that was going to imply that the threads starts from that point all the way to the downside. But now the two inner lines go all the way to the top side, which means the threads are all the way to the top like this. So now we are done with part number 5. Let's move over to part number 6, which is the pin of diameter 5, 30 millimeters long. Now you have two views given for the pin. You have the view at the bottom, which is the front view, and then you have the view at the top, which is the top view. So coming to our imaginary pin here, we have the front, and then we have the top right there. This is how the top looks like, and then the front side of the pin is just a circle of diameter 5. But this is the pin in reality. Alright, now we are done imagining the part in their 3D form, in their reality form. Now, after that step, you start the connection process. So now this is our part list. These are all the parts that we were given. So now you have to put everything together and come up with what? With a single component, with a single functioning component. That's what an assembly is. That is what an assembly it's all about. So now starting the connection process, we have the base. All the other parts, they should come together and go to the what? To the base. So let's go back to the question. Now let's analyze the base first. Remember, the question said you are required to draw an assembly drawing of a full sectional front view of the adjustable roller jack assembly. the full sectional front view, which means they only want to what? A front view. So this already is given as a front view for that base. Part number one is always the part that you start by when drawing an assembly. So this is the base, but this is the outside front view. This is just the front view of the what? Of the base. It's not the sectional front view. If you want to show the sectional front view, you use your sectioning skills. You imagine this thing being cut in half, and then how is it gonna look like from the front whereby this outside part of the front view it's gone? How does it look like now? Let's go over and do that. All right, now here is our front view of the what? Of the base. Now let's section the front. How is it gonna look like? It's gonna look exactly like this. This is the front view. Usually every time when you section something, let's look at the front view again. Usually you see there are hidden details that are flowing inside the what? Inside the part on the outside view. But now if this thing is cut in half, those hidden details they get exposed. You get to see what's on the inside because now they were being covered by the outer surface of the front view. That's why you were not able to see on the inside of the part, hence the hidden details. But now if the outer surface is being cut off, it's gone. That is whereby you see the inside of the part, which is something like this. Exactly like this. It's being cut in half. You are left with the half base like this. If we take it back to original, it's like this, and then it was cut in half. Now you get to witness the front view of it as like this. So now let's shift to another part that connects with the base. All right, now what we have part number two. Part number two, how does part number two connect with the base? You go to the base, you search for an equal dimension. You set for the dimension that's on the base that's also equal to the dimension that's on part number two. And since the front view of the part number two is like this, which means this is exactly how it's gonna connect to what? To the base. But first let's search for what? For the matching dimension. At the bottom side, we have diameter 18. Do we have anything else that is diameter 18 on the base? No, we do not have. Which means this part number two doesn't go directly to the top of the base, which means there's something that is of diameter 18 that plugs through the what? Through part number two, and then that thing that plugs through part number two is the same thing that is gonna be able to fit what? The base, because the base has a hole of diameter 30. Since the base has the hole of diameter 30, which means you have to find something else that is of diameter 30 that is gonna fit that hole, and then also at the top side of that component, this diameter 18 should be able to fit. So let's go get the extension. It is pretty obvious that in this case, the threaded rod, it's that part that we're looking for. We have diameter 18 at the top, which means that part plugs exactly on that roller cradle right there. It fits it. How thick is the roller cradle? It's of 12 units. How high is this head? Is 12 units. We have a hole in the middle, the hole of diameter 5. We also have the hole of diameter 5. So you see the connection there. If you can just take this rod and then push it up, it's gonna fit exactly at that hole of the roller cradle right there. And then focusing on the extension, the threaded rod itself, the body of it, it's of diameter 30, which is M30, same as the diameter. They've represented it of M30 because it's a threaded rod. So now we have 30, diameter 30. Remember, on our base, the hole is what? It's diameter 30. So now you were able to combine what? Three parts. This top part plugs on the top side of the rod, and then the body of the rod, it gets inside that hole of the base. The roller cradle is part number two. So let's shift over to part number three. We've already solved part number one, two, and five. So now what's left for us to solve is part number three, four, and part number 6. So now let's shift over to part number 3. Part number 3 is the roller. And remember, with the roller cradle, this is the roller, which means somehow this roller should be able to fit on the roller cradle right there. Focusing on the side of the roller itself. It has diameter 10 on the sides. Those tiny rods right there, they are of diameter 10. You go toward to the roller cradle, you have a diameter 10 space right there. And this opening of diameter 10, there's two of them because this is the front view of it. The side view looks like this, which means on the side also it looks like this, just like I've shown you on the 3D view. So this roller, it sits with this left hand side of it on the left hand side of the roller cradle, and then it sits with what, with the right hand side on the right hand side of the roller cradle. So how long is it? It's 94 millimeters long, which is the maximum length. How long is the roller cradle? 94 millimeters. So you see the what, the connection, the relation right there. This is how you search for connections. Even if you don't know what is going on, you don't know the part, you've never seen that mechanism before, it doesn't matter. You just search with the dimensions, and then you get to be able to solve the whole thing. And then the inner space of the roller cradle, it's 74. You shift, you search for 74. The 74, it's the what, is the second step of the roller. So which means now this part, the outer part of the roller right there, they are the ones that get inside these spaces. They sit right there, and they sit right there, and then these shoulders of 74, they are the one that touches from the inner space, going, filling up the whole empty space that is in the middle. And then now you are done solving part number 3. Shifting over to part number 4. So focusing at part number 4, what does part number 4 have in common with the other part? You search for it. You have the total length of 130, that is not common with the other part. But what is common with the other part, it is that M30. You see that M30 right there is the very same M30 that I've given you on the threaded rod. So what should that tell you? It should tell you that that rod goes through that hole. Whether you like it or not, this rod should go through that hole. But now, how does it go it? From the bottom or from the top? Now remember, you have the base, you have that rod fits into the base. On top of the rod, there is this roller cradle, and then on top of the roller cradle, there is a roller. So on top of the roller, you cannot fit this. This can only be fitted by what? By the body of the threaded rod. The adjustment wrench cannot fit on the bottom part of the what, of the base, because the base is an opening on the bottom side. It cannot fit right there, which means the only part where the adjustment wrench can fit is the top part of the base. Never mind the rod, because the rod goes through the adjustment wrench, and then it also passes through the base. So this is the roller cradle. The roller sits right there on those spaces, and then the threaded rod, it fills up that space. And then you have the adjustment wrench right there. The adjustment wrench, it sits on top of the base. If it sits on top of the base, you take the rod fits through that threaded hole of the adjustment wrench all the way to the hole of the base. And then on top of this rod right here, this is where this comes in. You see, you have something similar to what, to the head right there. Focusing on the top part of the threaded rod and then focusing on that hole, you see there's something identical there. You have this shape that has a tiny hole passing through, and then you have that another shape, and then you have the other shape on the roller cradle that has a tiny hole passing through. Obviously, the roller cradle sits on top of the rod in a way that this hole becomes in line with the hole for the roller cradle. And then the next part we have, it was the roller, and then you have the pin. The pin right there, which is the pin that locks the two parts. The pin locks the roller cradle, and the threaded rod. How does it lock it? Once these two come together right there, you have that one hole of diameter 5 passing through, and then this pin of diameter 5, it gets to be shoven on those holes to lock the two parts together. Everything, when it comes together, you have something like this. After all those parts are being solved, this is the end product. So let's zoom into the top side right there. This is how the roller sits on top of the roller cradle right there. And then the roller cradle itself, it sits on what? On top of the threaded rod. And then you have that diameter 5 hole. This orange part right there is the pin. Is the pin that goes inside, that locks the two parts. And then there's an adjustment wrench right there sitting on top of the base, and then there's a base as well. So this is what an assembly looks like. The assembly of all those parts, this is what it looks like. And then focusing on the front view of it, this is exactly the front view. But pay attention, this is the outside front view, not the sectional front view. So now, after being able to analyze what goes where, how, the next thing you do, you just start drawing. But then when you draw the parts, remember, you don't draw the outside views, you draw the sectional views of the what, of the parts right there. So we've already solved the sectional view of the base. So let's go solve the sectional views of the other part. So now we have the roller cradle right here. If we were to cut it in half right there, this is what we're gonna be left with when you look at it from the front view. So this is exactly what you put on top of the sectional view of your base, because now you have to connect all the parts but in a sectioned form. So this is the sectional view that you're gonna put in what, in the position whereby your roller cradle sits. Now we have the next part, which is the adjustment range. The adjustment range is right here, and then the front part, the front side of the adjustment range is this one right here. And then now we were to section it so that we're gonna be able to come up with what, with a sectional front view. You cut it in half all the way to the halfway point right there. How do you see it now from the front view? You see it exactly like this, with the internal threads right there, because that hole was represented as what, as M30 also. As long as there is M30 or M something, M25, it doesn't matter the number. As long as there is an M at first, it means that hole is a threaded hole. If you see a component that is labeled M and then there's a dimension on the side, it means that is a threaded surface. So here we have the adjustment range, sectional view of the adjustment range. You take it as it is, you go and seal it on top of the what, on top of the base, with the threaded rod going all the way inside right there. And then let's go to the other part. And then right here we have the front view of the roller, appears like this. Let's go ahead and section the front view of the roller. This is exactly what you have, smooth and clean. This is exactly what you're gonna see if this thing is cut in half. The front view of it is gonna appear exactly like this. There is no hole that is flowing through it, so each and every surface of it, it's affected by what, by the cutting plane. So let's shift over to the following part. Now the next part that we have this pin right here. Given the front view of the pin to be like this is the front view of the pin, and then if we were to section the very same tiny pin right there, we're gonna have something like this, cut it in half, and then the front view of it is just a whole surface that is sectioned. So now we are done sectioning all the parts. Notice how I didn't section the threaded rod, because engineering drawing 101, you do not section something that has threads in it. You do not section a threaded surface. That is the law, that is the rule. So now you know the front view of the roller jack appears like this. But now they do not want the front view. They want the sectional front view. So you take all those sectioned parts that you put together, and then you section the whole thing. And then after that, the sectional front view that you should be able to come up with after you've combined all your sectional front views of each and every part, connecting them together, it should result to something like this. This is what it should result to. So now remember, this was our sectional front view of the roller. This was the sectional front view of the roller currently, and then this is the sectional front view of the what? Of the adjustment wrench, and then we have the sectional front view of the base. So we have the threaded rod right there. The sectioning part doesn't affect the threaded rods because why? It has threads. There are things that you do not section on engineering drawing. First being this one, the threaded surface, you do not section the threaded surface. And then the web, something that has a web in it. When you get to that part whereby there is a web, you do not section the web. Those are the regulations. Those are the rules. So you have your pin right there. Zooming all the way to the pin, it's also cut, it's also sectioned. So now everything is cut in half. Everything is cut in half right there. This is the assembly of the roller jack. Sectional view of the roller jack. Everything is cut in half. It's put together and then it was cut in half. You find something like this. This is the answer of the roller jack. Now, the last thing to discuss is the sectioning part of the assembly. You see, if you pay attention to the sectioning lines of this assembly, you see the direction of the sectioning lines of the base. They don't have the same direction as the sectioning lines of the what? Of the adjustment wrench right there. The adjustment wrench sectioning lines, they are leaning to the other direction, which is the opposite direction from the sectioning lines of the what? Of the base. So my point is, if you are sectioning those parts, the point where there are two parts coming in contact, two different parts, that is where your sectioning lines start changing directions. So part number one is different from part number two. Those are two different parts. So they meet where at that line. So exactly at that line, your sectioning lines should change direction, exactly as it happened right here. And then same thing applies on this top side right there. The direction of the hatching lines from the cradle, they are different from the hatching lines of the roller itself. So two parts coming in contact, the hatching lines changes direction. That is how you should section your assembly each and every time. On each and every case, do not make the mistake of putting sectioning lines that flow through, that goes in the same direction all the way through the part. That is a mistake. You're gonna lose point with that. If you encounter a different part, you change the direction. Now, even on the top side right here, if there was a part that was in contact with the roller itself, the hatching lines were gonna change the direction to that side. They were gonna lean to that side right there, which is the direction that is opposite to these lines right here, because these sectioning lines, they go to that direction from the roller. So ladies and gentlemen, I hope you find this information useful. Now, if you encounter a problem when you were trying to put together the parts, imagining them in a 3D form or sectioning, I have other sessions, other classes whereby I focus on sectioning and the orographic projection. Everything is explained right there. So I suggest you go over and start with those classes before you get to the assembly, because the assembly is the more advanced part of the engineering drawing. The basics, I've explained them on the other classes. There is a class for sectioning apart, and then there's a class for photographic projection apart. So I suggest you go over and start there if there's something that you didn't understand here, because in this case we're focusing on what? On the assembly right here.